Okay, Assalamualaikum and a very good morning, good afternoon, good evening or good night. Hopefully you guys are doing well. Right, okay, now let's continue on the second part of the sample preparation, which is under the advanced extraction. Again, my name is Dr. Muhammad Afiq bin Mohamed Uri. Alright, so every great advance in science has issued from a new audacity of imagination. Okay, so we need to imagine. Okay, let's say we have the current issues. Okay, we need to think, we need to imagine the solution to solve the issue, so that we can advance the solution, okay, to counter the current problem, right? So by John Dewey, I'm not really sure who he is. Okay, so maybe you can try to Google it. I'm not really sure, but that's it about it. Okay, so we have learned a lot actually. Okay, we have learned on the conventional extraction method, which is the liquid extraction, solid extraction, and also solid phase extraction method. Okay, so we already done on that part. Also here we have now, okay, in this particular part we will focus on the advanced extraction method. Under advanced extraction method, actually there are a lot kind of advanced extraction method. Okay, so but I don't think that we can cover all. Okay, right now we can cover in this particular topic lah, we cover on the micro solid phase extraction method. Okay, we will look into the solid phase micro extraction method, and then we will look into liquid phase micro extraction method. Okay, liquid extraction and liquid phase micro extraction, the differences is about the volume of extractant lah. That's why we separate them. Okay, because liquid extraction over here in the conventional extraction method, it use a lot of solvent. Okay, high volume of solvent. But in advanced extraction method, most of the cases over here, they just need a tiny amount of solvent or no solvent required. Okay, so we will look one by one. Okay, so here is the thing that we'll cover lah. Okay, under liquid phase micro extraction, okay, we will look into the dispersive liquid micro extraction. Okay, and then we will look into the hollow fiber liquid phase micro extraction, and then we will look into the electro membrane micro extraction method. Okay, so we will look one by one. Okay, slow and steady. Okay, right, let's focus on the first one, which is the micro solid extraction. Okay, it's like SPE, but we micro, right? We make everything micro. We reduce the amount of solvent required, or we reduce the amount of sample required, okay, for this particular extraction process. So that's why we call it as the micro solid phase extraction. Okay, so under micro solid phase extraction, okay, there are actually different kind of the micro solid phase extraction method. Okay, so if you look over here, is the membrane protected micro SPE. Okay, membrane protected, we have the polymer type of membrane over here, and then inside here we will put our adsorbent, SPE adsorbent. Okay, so we fold the membrane. Okay, so after we put in the middle over here, okay, for example the membrane over here, and then we will fold, okay, into the desired size. Okay, and then we will seal. Okay, we will seal the edges, so we can secure the adsorbent from leaching out, or leaking out, right? So MIP is kind of polymer lah. It's kind of membrane imprinted polymer, if I'm not mistaken. Okay, we can seal. Okay, inside here our adsorbent. Okay, for example, non-polar adsorbent, or for example polar adsorbent, depends. Okay, so it gives you more flexibility. Okay, it can give you more freedom, okay, to adjust, for example, the size, or you want to adjust the size of adsorbent, the amount of adsorbent you want to put inside here. Okay, so this is very suitable for research study. Okay, so but for me, I think it's not really suitable for the real application lah. Okay, because you need to prepare every time. Okay, it's not readily available, you need to prepare by yourself. Okay, but if let's say for example in the analytical service, okay, okay, for example, I think it can be implemented, but for industrial purposes I don't think that it is suitable, okay, because it will take times to actually produce this particular thingy. Okay, so if you look over here, here is the membrane. Okay, we put inside here is the adsorbent, what kind of adsorbent that you really want, then you seal, and then you immerse inside of your sample vial, and then you stir the process. Okay, maybe 5 minutes, maybe 1 hour, maybe 2 hours or 4 hours. Okay, alright, so depends on your parameters of the analysis. Okay, right. Okay, right, so here again, the example inside here, we have the adsorbent enclosed within the membrane that we actually fold into envelope. Alright, so after you already extract the thing, and then you can dissolve your analyte of interest into another solvent. So you letak kat sini untuk adsorb, then you transfer into another bekas, you put the desorption solvent, okay, and then you can incorporate ultrasonication, okay, to increase the efficiency of extraction. And then after that, your analyte, kan tadi mula-mula analyte daripada this particular liquid dia akan masuk dalam ni kan, okay, dia akan terkumpul, dia akan attach, or it get absorb or interacted or do the complex session. Okay, depends what kind of extraction do you want to perform. And then here you transfer into another container, okay, and then you put the desorption solvent lah. So analyte that actually attached to the adsorbent or adsorb, okay, it will elute, okay, to the solvent over here, and then the solvent we can undergo the analytical analysis, okay, for example by gas chromatography, liquid chromatography, or capillary electrophoresis. Okay, so that is how it works. Okay, here is the example of application of the membrane protected micro SPE. Okay, if you look over here, alright, we have A, B, C. What is different? Okay, A is we using the micro SPE, B we using the HFM, if I'm not mistaken. I'm not sure, but HS is the heat space, HFM probably the immersion SPME. Okay, later on we will learn about the SPME. Okay, so they compare the micro SPE and also the SPME. If you look over here, that okay, the micro SPE can absorb a lot of analyte of interest compared to the SPME, because it has directly in touch, and then it has direct contact, it has much more surface area compared to SPME. Okay, SPME is very limited. Later on we will discuss on that particular extraction method SPME after this. Okay, so if you look over here, the micro SPE over here provide you better extraction, but of course, okay, in the micro SPE, because it's directly in contact with the sample matrix, so a lot of matrix will be extracted as well. Okay, if you look over here, a lot of noises as well. Okay, so that is kind of disadvantage of this particular method lah. Okay, but it also can give us benefit. Okay, so it can extract more, okay, which maybe some other kind of extraction method will not be able to do so. Alright, so that's it. Right, so here we have the organophosphorus pesticide. Right, okay. Right, so later on I will revert back to this graph if you want to compare the headspace SPME. HFM, I'm not really sure, maybe it's the direct emission, I will try to look again on that. Okay, okay, I have checked about the HFM SPME. Okay, okay, basically for the micro SPE, right now we already learned about the membrane, right? We already learned about the membrane. Why pointer option, laser pointer, why laser pointer, sorry, pen. Okay, so we already learned about the micro SPE, how it looks like. so you have the membrane that you fold, you seal, and then inside you have the adsorbent. Okay, so for the HS SPME, okay, so is headspace. Okay, I just show you right now. Okay, so here is your solvent and your analyte. So the fiber is just above the liquid. So headspace is mean that it doesn't immerse directly. So right now the other one we have the HFM SPME, which is we call as the hollow fiber membrane lah. So I think it's directly immersed lah. The fiber, hollow fiber, directly immersed in the solution. Okay, right. So if you look over here, that of course lah, usually the direct immersion we will provide you much more extraction, but of course the problem with that, you can also absorb all the interference. Okay, right. Okay, the next one. Okay, now is the active learning home assignment. Right, I will provide the link of submission inside of the e-learning. Right, so I would like you go to search about this journal, and then I would like you to draw the schematic diagram of the procedures. Okay, so just write the mapping. Just write the mapping of the procedures lah, like you write for the laboratory jotter book. Okay, so I would like you to do that and then upload the e-learning. So I hope that you can do that. Right. Okay. Right, here is the second type of the micro solid phase extraction. Okay, the first one we already learned about the membrane, and then here now we will learn about the pipette tip micro SPE. Okay, so in the pipette tip micro SPE, inside over here, inside the tip, like the, if you have used the micro pipette, okay, like this, right, we can put the adsorbent inside here. Okay, we can put the adsorbent inside here. Okay, the process is about the same with the normal SPE. So you have the conditioning. Okay, you have the conditioning, and then you can do the sample conditioning. Of course lah, you want to conditioning the adsorbent so it can readily interacted or effectively interacted with analyte of interest. Okay, so in loading, there are actually two type of method. Either you inject from above, or you can suck. Okay, you can aspirate the sample inside here. Okay, so over here, okay, is aspirate the sample and then suck a little bit more air. Okay, why is that? Because the adsorbent here is kindly now is berkumpul lah, they accumulated over here. So when we suck it air, okay, so we allow that much surface area to interact with our analyte of interest. That's why kita sedut sampai kita sedut udara lah. Okay, so ada cara lain adalah you sedut banyak kali. You lepas you dah keluarkan balik, you sedut balik. So you can do multiple time lah. Okay, to increase the amount of analyte interacted with the adsorbent inside here. Okay, so after that you can discharge back. Okay, to discharge, okay, you can do this process repeatedly lah. Sedut, masukkan udara, and then you discharge. You can do you can perform this repeatedly to increase the absorption. Okay, so the next process, not the last one, is to wash, and then you can use the washing solvent to remove all the impurities. Okay, and then you can do the elution lah using the right solvent. Okay, so here is the example lah. Okay, right. Okay, here is the example. Okay, here is the whole blood blank, and here is the whole blood extract. Whole blood ni apa? Adalah darah kita lah, whole blood. Darah merah tu kita panggil whole blood. Ya, kalau kata kita extract, not extract lah. Kalau you pernah demam darah, dia ada dua. Satunya whole blood kita ambil. Ada satu lagi dia ambil sebagai plasma. Okay, right. So that's about it. So above here is blank. Okay, here is the whole blood extract. Okay. So the whole blood blank ni mean that we just use the blood blank and we analyze it directly, right? But here is we use the pipette tips lah. Okay, pipette tip micro SPE. If you look over here, that by using the pipette tip micro SPE, it can help us to pre-concentrate the sample. Okay, it can help us to pre-concentrate the sample, so yeah, we can detect it better lah, especially if we dealing with drug. Okay, drug is easily derivatized. Okay, easily derivatized. So in just a few matter of time, okay, the amount of drug will be depleted. Okay, the amount of drug will be depleted and in trace amount. Okay, so we need the extraction process be able to pre-concentrate, okay, the analytical method, so we can detect them better. Okay, so this is a very good example lah, very good example of application of micro SPE. Okay, amphetamine, amphetamine ni dadah lah. Okay, you guys boleh try to look on it. Alright, I think the last one lah. Okay, under micro solid phase extraction method adalah bawah micro extraction by pack solvent. Okay, so here is the we call as MEPS, micro extraction pack solvent. So it's a miniaturization of SPE process. Okay, so daripada yang semua tadi, daripada membrane, daripada pipette tips ni macam tak berapa nak efficient ataupun not so nicely lah. Okay, so they invented the others, which is the micro extraction by pack solvent or MEPS. Right, so lab in syringe design, solvent material are packed in the small cartridge and is integrated in microliter syringe. Okay, if we look over here, okay, kat dalam ni ada ni, sebenarnya ada adsorbent dalam ni, small cartridge over here. Okay, only few microliter of elution solvent is required. It can easily be injected directly into GC or LC system, approximately 100 times less sample and solvent than conventional SPE technique. Okay, sangat-sangat sampel yang diperlukan. Okay, and then solvent pun tak perlu banyak. Okay, only few microliter of elution solvent is required lah, sikit sangat. So dia memang makin lama makin nak ke arah micro. Okay, now we look ya. Ni contohnya adalah syringe tadi. So kita akan sedut, kita akan keluar lah. So yang ni maksudnya aero atas, aero bawah ni kita sedut, kita lepaskan, sedut, lepaskan Right. Right. So here if you look here is the syringe. We have the frit ni macam block lah, filter kita tak nak kita punya SPE punya adsorbent, solid phase adsorbent kita ni daripada terkeluar lah. Okay, kita panggil nama frit. Okay, so kita sedut conditioning, kita sedut the solvent, and then we loading, we sedut, tarik beberapa kali. Okay, and then kita buat benda yang sama untuk washing process. Okay, to remove the impurities, and then we do the elution. Okay, using the right solvent. Okay, so this is the method by using the MEPS. Okay. Okay, here is the example of application. Alright. I'm not sure what is the differences. Is there any differences? Okay. Moving coding. Abundance. I'm not really sure what is the differences between this and this. 13. Okay. 12. The assay for enzyme realized horse using GCMI for microspeciation and micro. Okay, dia tak ada bagi tahu perbezaan apa benda dua ni. Mungkin lah, kalau if we look over here, this one it give much more cleaner chromatogram lah. Okay, so I believe this one after we use the MEPS, maybe here is direct extraction method. Okay, so it's not really successful to remove all the impurities. Okay, so kalau kita tengok, ini adalah peak codeine, ini adalah peak morphine. Okay, ini adalah paverin. Okay, and then noscapine, there is no noscapine. I'm not sure what went wrong. Okay, but using the MEPS, okay, it's nice. They remove all these things. So you obtain much more clear chromatogram. Okay, so I believe that is the thing that this example trying to say. Okay, now we are done with the micro solid phase extraction. Okay, nama memang lebih kurang. Okay, the name of the method is more or less about the same. Okay, but they are actually different. Okay, so don't get confused. Try to visualize more lah based on the figures, or maybe you try to look at the YouTube, try to Google the figures of the item, and then you can imagine. Okay, this is the micro SPE. Here is the solid phase micro extraction. Okay, because the name is just kat depan, kat belakang je kan. So memang agak mengelirukan lah, but I believe that you can do that well. Okay, so the next one we will look into the solid phase micro extraction. Okay, here is the history, blah blah blah, innovative, solvent free, rapid and versatile. Okay, the best thing about solid phase micro extraction is that you don't require to perform, you don't require to have any solvent. Okay, solvent free. Okay, so the principle based on the equilibrium establishment the concentration of analyte in the sample, if in the headspace of sample and in the polymer coating in the fused silica fiber. So SPME dia ada dua method. Satu yang saya kata tadi, kita ada contohnya ini you punya sampel yang sama, ini you punya sampel. Okay, dia dua cara, sama ada heat space, maksudnya you letak fiber you dekat udara, dekat above liquid lah. So the one is directly immersed inside of the liquid. Okay, so depends on the equilibrium. Kalau kata equilibrium kat sini lah, dekat udara ni, ini equilibrium dekat dalam air ni lah. Okay, right, the amount of analyte absorbed depends on the thickness of the polymer coating and on the distribution constant for the analyte. Okay, mode of the SPME is direct or immersed lah. Ini saya cakap tadi, kita ada direct, okay, kita ada heat space. Kita ada direct, kita ada heat space, ada dua. So the amount of analyte depends kepada amount of coating lah. Lagi tebal coating dia, lagi banyak dia boleh absorb. Okay, lagi besar dia punya fiber, lagi banyak boleh absorb. Okay, dan depends pada distribution constant lah. Okay, analyte tu kepada that particular coating. Okay, so the fiber is very fragile, and then yeah, that's thing lah, it's quite expensive. Okay, but later we will look into the cost effective. Okay, which one is much more effective lah. Okay, here is the method. Okay, how it's look like. Okay, right, if you look over here, we have the syringe. Okay, syringe here we have the fiber. Okay, fiber, and then we have the septum and everything. We have the protecting needle. Sebenarnya fiber ni dia boleh terkeluar, boleh keluar, boleh masuk. Nanti saya akan tunjuk, saya akan cuba record saya akan cuba tunjuk lah. Okay, the real SPME saya ada satu set, agak mahal sebenarnya. 3,000 lebih ke 5,000 agak mahal. So SPME, okay, ni this direct immersion versus the heat space. Okay, so depends kepada ni lah, distribution constant sebagainya. Okay, dan selepas kita sedut sebenarnya, kita boleh terus inject dalam GC punya liner. GC liner ni maksudnya dalam GC punya injection punya inlet tu, okay, or GC punya introduction punya system tu, kita boleh inject kat situ. So you tak perlu nak ada solvent, you tak perlu nak ada elution process. Okay, tak perlu tu, maksudnya you boleh terus direct. Okay, and SPME fiber, kalau kata we do the maintenance, okay, one fiber we can use 100 times, okay, more than 100 times, okay, usually lah. Okay, but if you don't use it carefully, okay, that's why it can get broken. Okay, because the fiber is quite fragile, actually quite fragile. Okay, here is another figure. Okay, right now here is the device lah. Device kat dalam ni kita letak fiber. Fiber ni kita boleh tukar lah, boleh tukar nak yang polar ke non polar. So depends lah. Okay, so dalam ni adalah fiber ni, sebenarnya dia tegak ni, dia melintang kan, it make it horizontal. Okay, it's supposed to be vertical lah. Okay, So over here dekat dalam ni kita ada support polymer lah, support polymer, okay, or support needle lah, support polymer or needle. Okay, dekat luar ni kita ada fiber ataupun the coating lah, coating polymer lah, yang the extractant punya adsorbent. Okay, so here is supporting material ya, this thing. Okay, dan yang ini bila dia dekat luar. Okay, so kita boleh sedut sebenarnya, kita boleh sedut. Okay, sebab dia fragile, this is fragile. Okay, so bila kita nak masuk dalam GC atau masuk dalam vial, takkan kita nak cucuk dengan fiber tu kan. So the fiber is fragile, we cannot penetrate the septum, okay, using the fiber, because the fiber is fragile, it can get broken if you try to penetrate the septum, okay, during the injection process. So you want to do the headspace inside of the vial. Mana yang vial tadi? Kan vial ni kan ada septum kan, septum ni getah, septum is made of rubber. Kalau you tak ada that particular, you terus penetrate using the fiber, it will get broken. So usually kita akan sorok dia, kita akan sorok dia dalam this particular tube lah. So tube ni tajam lah dekat luar ni, so the tube ni yang akan penetrate. After that kita boleh keluarkan fiber tu yang akan get heated. Okay, right. Okay, ini contoh yang lain Okay, ini contoh dia. Right. So yang ini, okay, inside of here is ada fiber sebenarnya. Okay, ada fiber. So kita akan penetrate dulu the syringe needle inside here, dan kita boleh turunkan fiber. So either you want to do headspace or you want to do the direct immersion. And then bila you dah nak keluarkan tu, you boleh tarik balik fiber ni masuk dalam untuk you protect dia daripada dia broken. And then you boleh tarik lah yang ni daripada sample vial. Okay, then you go towards the GC port, GC injection port, and then you can do the same thing again. You tak penetrate using the fiber is very costly. I already mentioned it numerous of time. Okay, because it's kind of expensive. Alright, then you when you do the desorption process, you just keluarkanlah that particular fiber, you turunkan fiber tu. So the heating process, dia akan evaporate the volatile components, dan dia akan masuk dalam GC column. Okay, that's about GC. Kita akan belajar on the GC part lah. Okay, right now desorption. Okay, here is the example lah during the HPLC or GC. I'm not sure where is the HPLC. Okay, so basically after you perform the GC, okay, evaporated analyte, okay, dia akan go inside the column dan dia akan detected by the detector lah over here. Okay, very simple. Okay, I will try to get my SPME over there. Wait for a while. Okay, right. Ya, ini yang SPME yang saya ada lah. It's quite large sebenarnya. Okay, saya tak pasti dalamnya ada fiber ke tak. Saya try. Okay, kalau you guys tengok saya tarik dulu. Okay, saya turunkan. Nampak tak ada yang keluar? Okay, saya tarik balik Okay, dia akan ada keluar. Oh, dah keluar dah. Mungkin tak nampak. Try to. Okay, move. Mana kamera? Okay. Yang keluar tu fiber. Nampak yang panjang-panjang? Itu fiber. Tak nampak clear sangat. Sorry So yang keluar ni adalah fiber. And this is quite expensive dekat 5,000 juga Mahal. Okay. Dan sebenarnya ada pelbagai dia ada pelbagai fiber lah. Okay, pelbagai fiber depends kepada ni you punya apa yang you nak guna lah. Okay, so kalau saya boleh keluarkan, okay, ni fiber kita boleh ganti benda ni. Kita boleh ganti, kita masuk dalam tu, kita boleh ganti sebenarnya. Alright, so kena berhati-hati, benda ni agak fragile. Dan this entire thing tak termasuk benda tu dekat 3,000 it's quite expensive. One fiber tu cost us about 700 lah. Okay, so we have four fiber over here, so it cost us about 2,800 saja. So sangat-sangat mahal Okay, that's it that I can show you lah about this. Okay, let's continue. Okay, here is the principle of SPME. Okay, macam ni saya rasa saya tak akan explain to detail the equation everything, but the thing that we need to know that here that the amount of analyte absorbed is directly proportional to the concentration of analyte in sample lah. Lagi tinggi concentration of analyte in sample, dia akan lagi banyak absorb dekat that particular analyte yang absorb lah dekat particular punya adsorbent. Okay, so kalau dekat sini dia ada kata juga, kalau kata volume of sample is very large, kita boleh neglect sebenarnya volume of sample tu dalam kita punya calculation. Sebenarnya kita boleh neglect, sebab dia kita guna micro amount of sample sebenarnya, just berapa tiny amount of sample sahaja. Orang kata tak lewah lah, tak membazir pun sample tu kan. Okay, but you may need only about less than 1 mil. Maybe you just need 0.5 mil of sample, because it's very micro amount lah. Okay, tak perlu banyak sebenarnya untuk SPME ni. Okay, so this makes SPME ideally suited for field sampling analysis lah. So sangat sesuai, dan dia portable sebenarnya, portable, dan you tak perlu solvent free pun. Okay, you boleh bawa dekat tempat sampling, you boleh immerse, dan you boleh simpan. Okay, you masuk dalam you punya bekas lah, dan bawa balik ke lab. Lab terus inject. Okay, very simple kan, very simple. So that is one of the best advantage of the SPME, other than mahal lah dia punya fiber tu. Okay, saya pun masih lagi berkira sebenarnya untuk buat project on SPME, because it's quite expensive of the fiber lah. Sebab saya takut juga kalau kata rosak, mahal. Okay, I already show you the fiber, right, the real one. Okay, so here we have a lot of type of fiber. For example, here PDMS, usually we look into the non-polar to semi-polar lah. Okay, analyte, type of analyte. Okay, so the other thing, like for example, we attach the divinyl benzene, or we have attached the carboxane onto the adsorbent, so we can go towards the more polar compound. Okay, for example, here divinyl benzene, okay, into the carbo wax, so we can increase the polarity, so it can interact more with the polar analytes. So it depends. Okay, if you look over here, this is the kind of the stationary phase also we use as the coating inside of the GC column as well. Okay, so it's about the same. Okay, kalau kita tengok sini kan, okay, yang inilah sebenarnya kita ada okay, different type of fiber kat sini. Sebenarnya tadi yang saya tunjuk tadi adalah yang inilah. Okay, okay, for manual use. Okay, yang ni pun manual use juga, dia tak ada auto juga. Right. Okay, so inilah fiber dia. Inilah dia punya needle. Fiber je tak nampak ni kat dalam ni. So dia kena tekan baru fiber tu keluar, macam tadi yang saya tunjuk. So even though SPME is quite costly on term of fiber, okay, tapi in term of long run lah, kalau kata long run, sebenarnya SPME ni agak murah. Ekonomi SPME ni sebenarnya dibangunkan oleh Dr. Amy, Dr. Prof. Wanaini, if I'm not mistaken, in the Dispersive Method Research Group lah, if I'm not mistaken lah, data pada diorang. Okay, kalau kita tengok sini lah, kalau kita tengok sini, the extraction time of course lah, SPME just about less than half an hour, they get the optimum condition. Okay, then the organic solvent memang langsung tak guna. Okay, solvent cost per year tak perlu guna, tak mahal lah. Okay, memang tak ada, so no solvent cost. Tapi kalau kata chocolate, bayangkan it cost us 1,000 lah per year. Okay, so utilities for SPME, apa je yang you letak dekat atas, paling habis pun you letak atas stirrer plate, so you can stir the solution, that's all. Okay, I don't think it goes to 120 lah. Okay, I'm not sure 120, if you divide by month pun just baru berapa, baru RM12, tak sampai RM10 je lebih kurang sebulan kan, not that much. Okay, So if we calculate, okay, in the socket, the timber, the cost of the per timber is around RM6 lah, the timber, one timber yang untuk socket tu, untuk sampel. So cost dia sebenarnya lebih kurang ya. Fiber memang lagi mahal, okay, tapi bila kita try to recalculate 100 time equivalent lah, kalau kata fiber tu tak rosak, okay. So meanwhile timber tu, satu timber tu kita boleh guna sekali je, tak boleh guna banyak kali, dia akan rosak. So kalau kita tengok sini, even though it's not that much lah the differences in term of manpower. Yang ni kalau kata manpower based on hours lah, okay. Kalau kata kita kira based on manpower per hour, kita memang beza dia sangat banyak, okay. Okay, tapi lah kalau you kata, okay, you complain, mana boleh kira macam doktor sebab kita dah bayar gaji tetap bulanan, okay, kita tolak lah, we exclude the gaji as the factor, okay. Kalau kita tolak gaji as the factor, still sebenarnya GMAT guna SPME around 800, around 1000 lah sebenarnya untuk per fiber tu. Cuma cost awal je you nak beli that particular device around 3000 to 5000, okay. So that's it lah about the SPME. Or do you have other? Okay, here is the example, okay, the application of direct injection versus the SPME. It means that, for example, you just doesn't do any preparation, just do direct injection, so a lot of matrix interference. But for headspace PME, it gave us there is no much interference, okay. We don't have this particular pattern of broadening, okay, that's good, right. That's an example. And then here is another example, alright, using the SPME, okay. Here is the heated headspace SPME, yang macam saya kata guna SPME fiber, or conventional heated headspace. Okay, conventional heated headspace ni apa? Okay, maksudnya instead of we inject directly, okay, the solvent, kita sedut kita punya sample masuk dalam GC tu, kita inject, okay. Instead of that, kita just inject apa yang ada dekat udara ni saja, tapi kita apply heating lah dekat this particular vial. So our analyte of interest yang volatile je akan evaporated. Okay, yang ni kalau kata kita guna conventional heated headspace, itu macam mana. Okay, kalau kata heated headspace SPME tu je yang ada fiber tu, so dia boleh attract more analyte, absorb more analyte, okay, much better lah, more efficient, okay. So if you look over here, it can give us much more better sensitivity of detection. Kalau nampak sini, alamak beza je macam langit dengan bumi, okay. Yang ini dia gunakan untuk analysis of methamphetamine. I'm not really sure. Okay, the detector is FYD at 250 degree Celsius. Okay, so SPME. Okay, SPME also can be automated. Okay, maksudnya dekat sini you boleh letak you punya syringe. Okay, macam tadi saya tunjuk tadi adalah manual punya SPME. Yang ni automated, kat sini kita boleh letak syringe dan kita boleh setting kat sini lah, automated SPME. Alright. Right, the advantages of the SPME large, okay, is incorporate sampling, extraction and sample introduction into single solvent free step. Okay, maksudnya buat semua benda sekali lah, kita sampling, kita boleh extract dan sample introduction, okay, tanpa memerlukan sebarang solvent. Okay, very simple lah, very simple. Okay, right, simple effective absorption desorption technique, eliminate the need for solvent, okay, compatible with analyte expression detection by GC or HPLC, reduce interfering background, making analyte identification and quantification more reliable lah. Okay, tapi ada juga disadvantage of the SPME lah. Apa yang bagus mesti ada kekurangannya lah. Nobody is perfect lah in this world. Okay, generally have good extraction properties compared to other, but some drawbacks, incomplete desorption or carry over problem lah. Okay, contohnya what it mean by incomplete desorption ni, maksudnya okay, you nak guna fiber tu untuk kali kedua. Okay, so you need to dissolve everything first. So you need to pre-condition dulu untuk buang the interference. Macam mana you nak boleh buang all that, you need kena masuk dalam, kalau kata dekat lab yang lain, dia akan ada satu tempat device untuk dia heating, untuk dia buang semua yang melekat dekat that particular fiber. Ataupun cara lain, kita boleh letak dalam kita punya GC tu untuk dia flow untuk beberapa minit, untuk dia make sure everything tak ada yang tertinggal, so you boleh run untuk second time. Tapi takut ada incomplete disruption, kita akan ada carry over problem. That's why if you want to run the second one, you need to run the blank one, kena berselang-seli sebab kita tak nak ada carry over problem. Okay, low thermal stability, generally bleeding at high temperature. Ingat, nanti you akan belajar dekat GC juga. Okay, dekat GC, the problem with that, the coating dia ni ada limited temperature stability. Okay, you tak boleh guna high temperature, dia akan rosakkan coating, dia akan rosakkan fiber. Okay, and then it has the low solvent stability. Bukan sebarang solvent je you boleh guna immerse that particular solvent. You tak boleh letak dalam acetone contohnya. Okay, acetone dia boleh rosakkan solvent. So ada solvent yang dia tak boleh, kita tak boleh nak masukkan fiber. Okay, limited extraction 40 to 100 lah. Okay, certain boleh go than that. Okay, expensive price fiber can go from 500 to 600. Ni price lama ni, yang baru ni tak boleh dah sebab kita punya mata wang agak jatuh. Okay, so cost is about 700 to 1000 ringgit lah per fiber. It's quite expensive, so that's the thing lah. Okay, right, now so the last one we will look into the liquid phase micro extraction. But under liquid phase micro extraction we have a few number of extraction method lah. That's the thing we will look today. Okay, mari kita tengok yang pertama. Yang pertama under liquid phase micro extraction is the dispersive liquid micro extraction. Okay, dispersive liquid micro extraction ni ada dua type sebenarnya. Okay, dia ada yang biasa punya, and then dia ada juga yang surfacting, floating, solidating, floating something. Nanti kita akan tengok nanti saya pun tak ingat. Floating organic. Okay, so dia ada dua type. Okay, ini the first type yang kita panggil normal, yang kita selalunya kita akan tahu, commonly know, okay, as the dispersive liquid micro extraction. So DLLME, nama pendek je, DLLME. Okay, the concept is about the same with the liquid extraction, but with the dispersive liquid micro extraction dia ada dua faktor lah yang membezakan dia dengan liquid extraction yang biasa. The first factor is micro extraction. So the solvent of extractant we use not that much. Okay, itu yang first factor lah. Okay, dia punya extractant solvent dia micro. Okay, and then untuk extraction process dia perlukan dua type of solvent. Okay, the first type is the extractant solvent, and then the second type is the disperser. Okay, disperser. Okay, right. So if you look over here in this particular procedure, okay, let's say here is your sample. Okay, then we will inject the solvent of extractant and also the disperser solvent. Okay, dia maksudnya you boleh inject sekali disperser solvent dengan extractant. Selalunya kita akan campur siap-siap lah the disperser dengan extractant tu sekali. Okay, contohnya you punya solvent you adalah benzene, you punya disperser you adalah acetone. Okay, contoh-contoh Okay, nanti kita akan tengok apa ciri-ciri disperser, apa ciri-ciri solvent extractant. Okay, so you akan inject both of the disperser and extractant solvent inside of the sample. Then because of certain characteristic of disperser, you akan nampak cloudy lah solution. So apa you akan buat untuk avoid the cloudy, you akan centrifuge untuk you nampak nanti akan ada the phase sedimented at the bottom. Okay, alright. So the phase ni adalah yang kita kata phase of extractant of solvent extractant kita. Solvent extractant kita akan ada di bawah. Alright. So you need to take this particular solvent extractant ni menggunakan syringe lah. You boleh sedut bawa naik atas. Okay, right. So yang ni yang the normal one lah. Normal one ni adalah you punya extractant solvent ni dia jatuh dekat bawah, dia density dia lagi tinggi daripada you punya matrix. Okay, yang ni yang normal. Nanti kita akan ada satu lagi DLLME SFO, kita akan tengok benda tu. So kat DLME ni kita ada banyak lah dia punya benefit je lah. Nanti kita akan tengok macam mana. Alright. Okay, ni antaranya adalah significance of DLME. Right, we consider simple, very simple, rapid, tak ambil masa lama, cost effective, not much of solvent, and dia bagi give high recovery and high enrichment factor. Kenapa? Sebab kita extract everything dalam kita punya extractor solvent. Okay. Kalau kata contoh you punya ni adalah 5 mil, okay, dan you punya extractor solvent you adalah 1, maksudnya daripada analyte you, daripada 5 phase yang pada 5 mil, dia akan pre-concentrate dalam you punya extractor solvent dalam 1 mil. Maksudnya dia akan 5 pre-concentration factor. Dia akan makin concentrate. Dia akan concentrate lah dekat you punya extractor solvent. So it's enrich. This extractor solvent will enrich. Okay, kalau kata contoh 5 mil to 1 mil kan. So dia akan reach 5 time. Bayangkan kalau kata sample you 10 mil. Okay, dan you pre-concentrate dalam 1 mil. So ia akan jadi 10 mil pre-concentration factor. Okay, dia akan lagi pekat 10 times. Okay, right. So that's why it can give us high recovery and high enrichment factor. Consume small volume of organic solvent with higher density than water. Yang ni normal DLLME DLLME. Nanti saya akan cakap the second one lah. Okay, kita akan bincang about the second one. The DLLME method contribute towards green chemistry and maintain the environmental water resources and human health from high volume of organic solvent. So it contribute to green chemistry because we just use minute amount of solvent. Okay, so we can maintain water resources and everything because we don't really, maksudnya menyumbang kepada penggunaan banyak solvent yang berbahaya lah, sebab nanti kita akan dispose at the end kan, the particular solvent. So it contributed to the sustainable chemistry and also green chemistry. Okay, okay, here is the procedure I think I have described about it. Okay, right. So the first one, let's look over here the selection of extraction solvent and dispersive solvent. Right, in the normal DLLME, extraction solvent have to fulfill some requirements such as high density than water lah. Okay, usually high density, not usually lah, that's why we call DLLME. Kalau kata we use the density that lower than water, okay, we name it as the DLLME SFO. Later on we will go into that. The extract solvent must be high density than water, so it will go towards the bottom, sedimented at the bottom, and then low solubility in water. Okay, so it will not be miscible. Okay, so that if they are miscible, we cannot perform the partition process. They are not forming of two layers, so it will be difficult for us to extract them. High extraction capability for target compounds. Okay, must have very good Kp value, right? Low volatility, right? Because we don't want it to easily evaporated. Okay, example over here is dichloromethane, chloroform, bromobenzene, carbon disulfide, and carbon tetrachloride. So among these, we have the polar and non-polar as well. For example here, carbon disulfide is non-polar. Okay, it's not that really polar. Chloroform is quite polar. Bromobenzene is quite polar. Dichloromethane is quite non-polar. Carbon tetrachloride is quite non-polar. It's non-polar lah. It's about non-polar. Alright. Okay. That is for the extraction solvent. How about dispersive solvent? Okay, this is the thing that we need. Okay, so that it can give us a very efficient recovery. Okay, so dispersive solvent, the function of dispersive solvent is to disperse the our extraction solvent very well inside of the sample. Okay, that's why dia akan wujudkan cloudy, sebab dia, okay, dispersive solvent must be able to miscible in both aqueous sample and also extraction solvent. Dia kena soluble, kena miscible dalam both aqueous sample and extraction solvent. That's why bila benda ni berlaku, dia akan wujudnya cloudy. Okay, dia wujudnya cloudy. So it means that dia akan dispersekan our punya extraction solvent very well inside of that particular sample. Okay, so after we have properly dispersed, and then we centrifuge it so it can sedimented to the bottom. Alright, so example here, acetyl, methanol, ethanol, and acetyl nitrite. This is the example of the dispersive solvent. Okay, dispersive DLME, fine drop extraction solvent containing fine drops, okay, very well dispersed, okay, of the extraction solvent containing analyte settled in the bottom of test tube due to the high density of the extraction solvent and water. Maksudnya kita punya extraction solvent ni akan well dispersed. Okay, well dispersed, dan dia akan pergi secara keseluruhan. Okay, kita punya sampel. Advantages: simple, rapid, low cost, high recovery and enrichment factor. Disadvantage: use toxic solvent. We still use toxic solvent. Macam you tahu kat sini ada banyak lah yang berbahaya, macam dichloromethane, carbon disulfide is quite toxic. Walaupun kita guna minute amount, but it's quite toxic, so you need to be very careful if you try to use this particular method lah during the extraction process. Alright. And the other disadvantage of the LME is the sample must be clean enough lah. You need to have a sample preparation lah. Sample wrap preparation, you need to filter first, and then after that only then you can perform the dispersive liquid microextraction. If not that, you have some undissolved solid or some impurities. The problem is that the normal DLME, the extraction solvent will be sedimented at the bottom, so kita tak nak dia bercampur dengan impurities yang tak dissolve. Okay, right. So a lot of application, for example here, try to analyze phthalates, ester, chlorobenzene, blah, blah, and everything. Number of metrics and number of instrument. Okay, so a lot of application, okay, have been developed for the LLME. Okay, alright. Oh yeah. Okay, this is the previous one. Okay, again the extracted and dispersed solvent. Okay, mix together, and then we take some, inject into our sample, so it become cloudy. That is okay, don't get scared. And then centrifuge. Okay, so it's settle phase, and then we withdraw for the next analysis. Alright, here is the other DLLME that I talked to you about, which is the DLLME SFO, or solidification of floating organic drop. Okay, DLLME SFO, solidification of floating organic drop. Okay, kalau dekat sini beza dia adalah extractant solvent kita tu kita guna lower density than the sample. Okay, lower density than the sample. That's it. Okay, so it will still form the cloudy, okay, as cloudy phase, and then we centrifuge, so we can make them spread better, right? So the other thing is about the same lah. It's about the same. Okay, right. If you look over here, most of the time, okay, since the extractant solvent, okay, we can use the one that actually has lower density. Most of the organic solvent, okay, can be come from non-toxic kind of solvent, such as the dodecanol, andecanol, and decanol. Okay, but the time of the application over here, you need to use the solvent that have a long chain of alcohol lah, so they can separate from aqueous solution, right? Okay, the application of dispersive liquid microextraction yang SFO lah, solidified organic drop tu. Okay, the application similar like the normal DLLME, so a lot of application for this particular extraction method. Okay, now let's look on the second last, the liquid phase microextraction, which is the hollow fiber. Okay, the hollow fiber, we use the fiber, but inside of the fiber is hollow, maksudnya dalam tu je macam ada ruang kosong lah. So the hollow fiber is kind like of filter, it separate, okay, the matrix interference, okay, from the sample matrix, dan kita akan letak dalam hollow fiber ni kita punya extractant solvent, dan yang bertindak sebagai acceptor phase. Okay, dalam hollow fiber ni, HLPME ni, HFLPME ni, kita akan dengar dua term lah yang baru, iaitu acceptor phase dengan juga donator phase. Acceptor phase ni maksudnya you punya solvent yang you nak accept the analyte. Donor phase ni adalah you punya sample matrix yang akan donate the analyte. So macam ni lah. So dalam ni dia ada is hollow, ada free space area, so you can put your extractant solvent dalam ni, ataupun you punya acceptor phase. So kalau tengok sini adalah wall of the fiber, so it just very small in size, so it just small enough to spread, okay, the sample interference, dah ada sample interference outside of the membrane, ataupun dia bertindak sebagai filter untuk remove all the impurities. Okay, so here how it works for the hollow fiber membrane extraction. Okay, kalau kita tengok sini ada sample vial, kita ada this sample ataupun dia bertindak sebagai di donor phase, dan kita akan ada fiber. Dalam fiber ni adalah hollow fiber, dia ada empty spaces, so we can put our organic phase ataupun kita panggil extracted solvent ataupun yang boleh panggil sebagai acceptor phase. Okay, so fiber ni kita akan attach dekat this particular needle lah, dekat syringe ni, syringe needle. So bila kita attach the hollow fiber dekat syringe needle ni, kita boleh inject kita punya acceptor phase, kita letak dalam this particular vial, dan kita boleh stir the solution lah, depends pada berapa lama yang you nak. Okay, so you punya analyte dia akan interact with the acceptor phase, okay, inside of this particular hollow fiber. So the syarat dia adalah, okay, the acceptor phase must be, okay, the acceptor phase must be immiscible. The acceptor phase must be immiscible with the sample metric. Okay, kalau sample metric kita aqueous, kita kena guna acceptor phase yang non polar lah. Okay, kalau kata kita punya donor kita adalah polar, dalamnya adalah non polar. Kalau kita punya donor kita adalah non polar, dalam kita punya acceptor phase ni adalah polar. Okay, so dia kena ni, sebab kalau tak nanti dia akan leaching out. Okay, so lepas kita dah perform the extraction process, after certain minutes we can extract back the acceptor phase, dia boleh sedut, kita boleh masuk dalam another vial. Okay, kalau contohnya macam dalam ni you dah ada about 20 microliter, tak ada masalah, so you boleh terus run guna GC lah kalau you guna GC, sebab GC most of the time injection is about 1 microliter, 0.5 microliter, 1.5 microliter. Okay, that's it. Tapi kalau contoh macam HPLC, sometimes you need 10 microliter to 20 microliter. So you may need to reconstitute lah, sebab maybe you want to do replicate analysis kan. So depends, okay, kepada that particular factor as well. So in hollow fiber membrane kita ada dua configuration berbeza. Okay, the first one, normal one macam ni lah. So just the rod shape fiber, maksudnya just straight way macam saya explain tadi, very simple. And then we can use this particular configuration, which is the U-shaped fiber. Okay, in the U-shaped fiber give us good advantages. Okay, for example, kita boleh letak lagi banyak lah kita punya sample donor solution, dan kita boleh replace the donor solution continuously lah. Maksudnya kita mungkin, okay, kita full untuk yang pertama dan kita extract, lepas kita tambah lagi, kita extract. So we can do it more or less likely lah. Okay, more or less continuously lah, walaupun not really continuous lah. But I believe science, macam yang kita tahu in the quotes earlier, science is the advancement of the imagination kan. So kalau kata kita boleh automated this particular system, okay, it will be a great, okay, factor to science. I'm not really sure dah ada ke tidak, but that is the idea lah, how we can do that. Right. Okay, the hollow fiber usually made of polypropylene lah. Okay, polypropylene made of polymer lah, senang cerita. Alright. So ini gambar yang lain. Okay, kita ada A adalah donor phase, dia punya sample. B adalah hollow fiber. Kita boleh letak dekat sini hollow fiber ni, kita boleh impregnate sebenarnya dengan coating yang polar ataupun coating non polar, depends kepada you punya extraction. Kalau you tak nak ada coating pun boleh. Okay, so nanti kita akan belajar, sebab dalam HF LPME ni dia ada dua sistem lagi. Tadi configuration dan dua sistem, which is we have two phase system and then you have three phase system. Okay, kita akan tengok benda tu sekejap lagi. Okay, so bila dekat dua phase system, dia tak perlukan impregnation of the coating, ataupun tak perlukan coating dekat this particular fiber lah. Kalau kata three phase system, you may need to coat ataupun you need to impregnate the membrane over here, ataupun you need to impregnate the fiber over here with the particular kind of solvent lah. Okay, you perlukan. Kalau kita tengok sini, okay, analyte of interest akan interact with the acceptant solvent ataupun acceptor phase, dan you punya interference impurities will be left out lah, dia tak akan masuk dalam. Okay, bukanlah kita kata oh memang kita akan dapat purely lah, tapi kita dapat remove lah analyte, a lot of impurities. Contohnya macam this is aqueous and then this is the polar non-polar extractant solvent. Okay, so kita boleh remove the interference come from polar interference. Okay, so at least we can reduce the interference. Okay, it can give us better purity of the analysis. Okay, alright, here what I talked about you before this, we have two-phase system, okay, and also three-phase system. Right now I would like to explain first about the two-phase system first. Okay, in the two-phase system is suitable for hydrophobic analyte, maksudnya analyte yang tak suka air lah, kalau kata sampel dia air lah, tapi dia boleh vice versa. Okay, but most of the time is suitable for hydrophobic analytes. Kalau kata kita dealing dengan air, so kat sini dalam ni kita akan letak organic solvent which is basically non-polar. So of course lah, benda yang suka non-polar is hydrophobic kan, hydrophobic, dia tak suka air. Okay, so inilah antara contoh dia. Alright, kalau kita tengok sini ada dua phase je, ada donor phase, ada acceptor phase lah. Right, now let's look on the three-phase system. Okay, in three-phase system, okay, we have a donor phase, we have the organic phase, and we have the acceptor phase. Dekat sini sebenarnya mana you nak, sebenarnya in three-phase system ni you try employ, contohnya macam you ada hydrophilic analyte. Okay, analyte you hydrophilic, suka air, tapi macam mana you nak extract from water kan? Okay, so this how you can do it. Okay, you buat 3 phase, maksudnya donor phase, organic phase and acceptor phase. Tapi syarat untuk 3 phase system ni is limited to analyte that ionizable. Okay, basic or acidic analyte is ionizable. Contohnya macam amino acid, contohnya macam drugs yang kita boleh analyte. Contohnya macam drug lah, amphetamine. Okay, dia akan ionize dekat lower pH. Okay, dia akan ionize at lower pH. So apa yang kita boleh buat, dia akan ionize kat lower pH. So kita boleh increase the pH inside of donor phase supaya dia jadi neutral. Bila dia jadi neutral, dia akan reduce its polarity lah. So dia akan boleh maksudnya sedut dalam this, maksudnya dia akan terlekat dekat this particular organic phase yang kat tengah-tengah ni yang kita impregnated with the organic solvent. Okay, dia akan impregnated, dia akan interact. Okay, kemudian dekat dalam ni, sebab bila kita nak increase the polarity, kita nak attract more, contohnya macam tadi amphetamine, dia ionizable dekat lower pH, so dia prefer that particular one. So kita boleh adjust this acceptor solution aqueous phase, kita boleh adjust supaya acidic. So basic, neutral. Okay, so in basic and here also neutral lah, nothing kan. Okay, so dia akan transfer sampailah dekat sini, dia akan ionizable. So inilah syarat-syarat dia untuk three-phase system. Okay, alright. Okay, now let's look on the electro membrane extraction. Okay, electro membrane extraction is more or less about the hollow fiber triple phase system, or three-phase system, more or less, still using hollow fiber. So inside here we have the acceptor solution, dan the hollow fiber kita ada impregnate with the solvent lah. Okay, so it's about the same. The differences with that, we connect with the electrode and power supply to increase the speed of the extraction process. But to one of the advantage of the EME is the fast extraction process. So dekat sini you apply, contohnya macam you nak extract. Okay, you want to extract the positive analyte, positively charged analyte, cation. So here you have cathode. Cation love cathode. Cathode is negative electron. So you need to use this particular configuration. Let's say if you want to extract, you want to extract the negatively charged analyte. So you need to reverse the polarity. Okay, so you need to change here as the positively charged electrode, which is the anode, so that it can attract an ion, which is negatively charged ion. Okay, right. Okay, so the advantage is fast extraction process. Activity can be implemented by organic solvent, polarity and bentuk advantage. Kita cakap tadi kita boleh play around with the organic solvent implemented with the ni liquid membrane ni, dan kita boleh adjust the voltage lah untuk fasten or reduce the speed of the extraction process. Tapi ada drawbacks lah kat sini. Kita boleh lost the extractor solvent, ataupun kita boleh lost apa organic yang solvent yang kita ada impregnated kat sini kalau kata kita tak optimize it well lah. Okay, just a little agitation or strong electrical field dia boleh mengacau bilaukan lah, atau kita boleh lost the acceptor solution, and also this one. So you need to be very careful as well in the electro membrane extraction. Mungkin ada sampai certain situations, certain voltage sahaja kita berjaya. Okay, mungkin more than that it will damage the entire extraction process. So a lot of adjustment needs to be considered. Okay, right. So here is the extraction parameter we can adjust. For example, apply voltage, berapa voltage kena apply, sample agitation rate, you nak stir macam mana, sample pH, depends kepada you punya acceptor or the donor phase pH, extraction time, berapa lama you nak apply that particular extraction method. Okay, so a lot of parameters you could alter lah, okay, to determine the best efficiency of EME. Okay, right now is the electrophoregram. Okay, in GC or HPLC, gas chromatography or high performance liquid chromatography, we use chromatogram. In ATR, FTIR or spectroscopy, we use term spectrum. For the CE, capillary electrophoresis, we call this as the electrophoregram. Okay, so saya tak nak you guys confuse lah kenapa saya guna electrophoregram. Okay, so basically macam chromatogram, tapi sebabkan it produced by the CE, because we use the electricity as the expression process, so that's why the term electro is there. Okay, electrophoregram. So dekat sini tengok berjayalah dia extract drug, okay, drug from human plasma lah dia extract. So now is the general conclusion. Okay, most of the extraction method that I told in the advanced extraction method is the under micro extraction method. Okay, right. So the best thing about the micro extraction method is simple, fast, okay, cost effective, virtually solvent free, readily automated. Virtually not really lah, tapi macam SPME memang solvent free, readily automated. Kita boleh buat automated, contoh macam SPME. Okay, we can make it automated. Offer increased sensitivity, sebab dia selalu micro extraction method ni kita akan ada enrichment factor. Maksudnya daripada sampel 5 mil tu kita akan pre-concentrate into contohnya 1 mil, ataupun kita try extract semua dalam that particular small solvent extraction system. So maksudnya dia akan ada pre-concentration factor. Daripada tempat yang banyak dia pergi yang kecil, of course lah dia akan makin pekat dekat tempat yang kecil tu. Okay, so it's offer increased sensitivity, potentially applicable in various fields. Saya rasa kita dah bagi contoh banyak kat sini, drug analysis, environmental, pesticide analysis, food analysis. So a lot of thing. Okay, advantages of micro extraction technique. Okay, tapi kalau you tanya saya method mana yang paling yang recognizable lah dalam among the micro extraction technique ni, adalah SPME lah. SPME yang paling banyak digunakan lah. Okay, yang lain tu ada a lot of limitation as well lah, ada a lot of limitation as well compared to SPME. And SPME of course the easiest one lah among all, just the device is quite expensive, that's all. Okay, so that's it about this particular chapter. Alright, so we will have discussion next week. Thank you.